22nd question. A rocket rises up in the air due to force generated by the fuel. The work done by the fuel. So my dear children, we know the rocket rises up in the air because the fuel exerts an upward force. So force is in the upward direction and displacement of rocket is also in the upward direction. So work done by fuel is positive work. So fuel is positive work done, and we know very well gravity, force of gravity. Force of gravity is acting towards the center of the earth and displacement in the upward direction. So the angle between them is 180 degrees. So work done is negative. So fuel is positive work and force of gravity is negative work. Next, 23rd question. A ball of mass 1 kg thrown upwards reaches a maximum height of 5 meter. Calculate, calculate the work done by the force of gravity during this vertical displacement. So my dear children, a body of mass 1 kg is thrown upwards and reaches a maximum height of 5 meters. So work done by gravity is equal to, we know very well, that is work done equal to force into displacement. In the place of force, right here weight. So because work is done by gravity, so force is nothing but weight of the body, that is mg, and displacement is h. So in the place of mass 1 kg, in the place of g 9.8, in the place of h 5 meter, that is equal to 8 5 40, but 40, that is equal to 49 joule. But here force and displacement are, the angle between them is 180 degrees. So the work done is negative. So the answer is minus 49 joule. Option 2 is the right answer. Next, go to 24th question. 24th question. A brick was lifted from the ground to a height h in 3 different ways. In which case was the work done against gravity maximum? Here, my dear children, work done depends on initial and final points. It does not depend on the path. So here initial and final, so join, the displacement is h. Here initial and final displacement is h. Here initial and final displacement is h. So in the 3 cases, in 3 ways, the displacement is same and weight of the body is same. So work done is equal in all above 3 cases. So option 4 is the right answer. Next, go to 25th question on kinetic energy. Right. When speed of a motor car increases 6 times, then kinetic energy increases by. So we know very well kinetic energy is equal to half mv square. Here v means speed of the motor car. So your speed increases 6 times. Speed increases 6 times. So now this time kinetic energy dash equal to half m. In the place of v, right here 6v whole square. That is equal to half mv square. 6 square means 36. So kinetic energy is increased 36 times. So 36 times. If speed increases 6 times, kinetic energy increases by 36 times. Next, 26th. The kinetic energy of the body is increased most by doubling its. So kinetic energy is equal to half mv square. Here m means mass and v means speed. If speed increases, kinetic energy becomes maximum. That means if speed double, kinetic energy 4 times. If speed triple, kinetic energy 9 times. So kinetic energy of the body is increased most by doubling its speed. By doubling its speed. So 26, option 3 is the right answer. Next here, 27th question. A graph was plotted between kinetic energy and velocity of the body. Which of the following represents correct graphical relation? We know very well kinetic energy is directly proportional to square of the speed of the body and velocity of the body. Suppose kinetic energy is 1 joule. Kinetic energy is 1 joule. Graph is between B and D. Okay, right. If velocity is 1 meter per second, then kinetic energy is 1 joule. If velocity is 2 meter per second, then kinetic energy is 4 joule. If velocity is 3 meter per second, the kinetic energy is 9 joule. The kinetic energy is directly proportional to square of the velocity of the body. So his graph is not linear. The graph, that means the graph is bending towards the positive y-axis. So option 2 is the right answer. Next go to 28th question. What is the mass of a body which has 5 joule of kinetic energy while moving at a speed of 2 meter per second? So we know very well kinetic energy equal to half mv square, that is equal to half in the place of m, in the place of m, write m, v in the place of v, in the place of v 2, so that is 2 into 2 square. Kinetic energy is 5 joule. 2 gets cancelled, then m is equal to 5 by 2, that is equal to 2.5 kg. So option 1 is the right answer. Next year 29th question. An 800 Newton car is traveling at 12 meter per second along a horizontal road. When the brakes are applied, the car skids to stop in 4 seconds. How much kinetic energy does the car lose in this time? How much kinetic energy does the car lose in this time? That is nothing but a change in kinetic energy. Change in kinetic energy nothing but final kinetic energy minus initial kinetic energy. So the car stops. The car stops means final kinetic energy becomes 0. That is equal to minus kinetic energy. That is equal to minus half m u square. So here mass is not mentioned. So we can write here car weight is given, that is 8,000 Newton. So we can write W equal to mg. From this m equal to W by g. So in the place of m write W by g, that is equal to 8,000 Newton by 9.8. So here g value is given 10. So 10. So right here minus half in the place of m, 8,000 by 10, u is 12, that is 12 into 12. So 0 gets cancelled, 2 1 2 6, that is equal to 576. 6 into 12, 72 into 8, that is 576 into 100 joule. You can write as 5.76 into 10 to the power of joule. So option 3 is the right answer. Let's go to 30. The weight of an object on the moon is 1 by 6 of its weight on earth. The ratio of the kinetic energy of a body on earth moving with speed v to that of same body moving with speed v on the moon. So kinetic energy on earth, kinetic energy on moon is equal to, we know very well kinetic energy is equal to half mv square. So here mass is same, mass remains same. So mass remains same, wherever you go mass remains same and the same speed. So the ratio is equal to 1:1. 31st question. The kinetic energy of an object of mass m moving with a velocity of 5 meter per second is 25 joule. If the velocity is increased by 3 times, the kinetic energy is the kinetic energy of an object of mass m. So kinetic energy is equal to half mv square. So kinetic energy is given 25 joule equal to half m and speed is given 5 meter per second. So we can write 5 into 5. So 25 gets cancelled, mass is equal to 2 kg. Then if the velocity is increased by 3 times, it means 3 into 5, that is equal to 15 meter per second. Then the new kinetic energy equal to half in the place of mass 2, velocity is 15, that is 15 into 15. 2 gets cancelled, 15 into 15, that is equal to 225 joule. Option 2 is the right answer. Next, 32nd question. When the speed of a particle is doubled, when the speed of a particle is doubled, the ratio of its kinetic energy to its momentum. So first write kinetic energy to momentum. Kinetic energy by momentum is kinetic energy equal to half mv square. Momentum is equal to mv. M gets cancelled, vv gets cancelled, that is equal to v by 2. If speed is double, then find ratio. If speed is double, that is half m. If speed is double, in the place of v, write 2v, then it becomes 4v square. Then momentum m into 2v. mm gets cancelled, 2 into 2, 4, 4 gets cancelled, V. That is V. That means if speed is doubled, kinetic energy how many times increases? For this, if you multiply 2, then it becomes V. So if the ratio of kinetic energy to its momentum gets double, initially it is V by 2, then V. That means how many times it is increased? 2 times it is increased. So gets double. So 33 question. 33rd. The momentum of a body is numerically equal to the kinetic energy of the body. What is the velocity of the body? So momentum of a body is numerically equal to the kinetic energy of the body. So that is P equal to kinetic energy of mv square. Then what is the velocity of the body? In the place of momentum, write mv is equal to half mv square. Mm gets cancelled, so vv gets cancelled. Then velocity is equal to 2 meter per second. That is velocity is 2 units. 2 units. Next, 34th. When mass is halved and velocity is doubled, the kinetic energy of a body is. So first write kinetic energy is equal to half mv square. Then kinetic energy dash equal to half in the place of mass. Mass is halved and velocity is doubled in the place of it 2v whole square. So it becomes half mv square. V square. So here this is 1 by 2, 2 square, that is 4. So 2 1 ja, 2 2 ja. That is equal to half of v square into 2. In the place of half of v square, they get kinetic energy. So kinetic energy is double. Kinetic energy is double. So option 3 is the right answer. Double. Next, 35th question. A 1 kg mass has kinetic energy of 1 joule when its speed is. So it is very easy. Kinetic energy equal to half mv square. Kinetic energy is 1 joule. That is half mass 1 kg. Speed v square. So v square equal to, if 2 comes this side, that is 2. Then v is equal to root 2. Root 2 means 1.414. That is meter per second. So 1.4 meter per second. Option 2 is the right answer. Next, go to 36th question. It is based on potential energy. Water stored in a dam possesses. Direct question. This is potential energy. Next, a golf ball is struck by a golf club and falls on a green 3 meters above the tree. The potential of the ball is greatest. The potential of the ball is greatest, you know very well. Potential energy is directly proportional to height. It means if the height is greatest, potential energy of the ball also greatest. So the potential of the ball is greatest when the ball reaches the highest point in its flight. Option 4 is the right answer. Let's go to 38th question. A 2 kg block is thrown upward from a point 20 meter above its surface. At what height above its surface, the gravitational potential energy of the block is increased by 500 joule. See, my dear children, I am doing this one. Side. Source here. 38th question. So 38th question, a 2 kg block. A 2 kg block is thrown upward from a point 20 meters above its surface. Above its surface. Which question this is? 37th. 38, okay, 38. Right. See, this is the earth surface above 20 meter. Above 20 meter, a 2 kg block is thrown. Okay, first here at this point is A. At point A, it has potential energy. This potential energy we can call as initial potential energy. So that is equal to mgh. So mass is given to g value 10 meter per second square, height 20. So that is equal to 400 joule. So initial potential energy is 400 joule. Next, so it is thrown. It reaches some height. So it reaches some height. At what height above its surface, the gravitational potential of the block is increased by 500 joule. Suppose at this point B, the potential energy is 500 joule. So it means required potential energy up to here 400 joule. When it reaches here 500 joule. So we can write required potential energy is equal to initial potential energy plus 500. That is equal to 400 joule plus 500 joule, that is equal to 900 joule. Suppose this is H height, this is H height, so we can write required potential, that is mgh. So mass to G10, height h is equal to 900. So 0 gets cancelled, x equal to 90 by 2, that is equal to 45 meter. So from its surface 45 meter, the gravitational potential of the energy is increased by 500. So option, check the options. Right, 45 meter, that is option 3 is the right answer. Next 39th question. A body at rest can have. A body at rest means velocity is equal to 0. Velocity is equal to 0. Can I have velocity? No. Kinetic energy means is equal to half mv square. So a body at rest means kinetic energy is 0. So momentum means mass into velocity. When the body has velocity, then only body has momentum. So potential energy, because potential energy is equal to mg height. It depends on the height from its surface. So a body at rest can have potential energy. Suppose a body is lifted to a height h and it is placed here. Now this body has potential energy. So option 3 is the right answer. Next, an object of mass 1 kg is raised to a height h. Its potential energy is increased by 1 joule. Find the height h. Direct question, potential energy is equal to mgh. So mass is 1. So G value 9.8. Height is h. Potential energy is 1 joule. From this h equal to 1 by 9.8, that is equal to 0.102 meter. So option 1 is the right answer.